The number you have dialed has been changed.
Hello everyone, welcome back again to our channel. So for today's content, this is a video tutorial problem solving involving percent by volume and expressing the concentration of the solution, problem solving in boiling point elevation, and calorimetry. There are 6 ways to express the concentration of the solution: percent by mass, ppm or parts per million, molarity, molality, mole fraction. And for our first example, we will use percent by volume. The formula for percent by volume is volume component of the solution divided by the total volume of the solution times 100. First example, 35 ml of ethyl alcohol is present in 250 ml wine. What is the percent by volume? In solving a problem, you should first identify what is asked and what are the givens. So we will find the percent by volume of the concentration of the solution. Given 35 ml of ethyl alcohol, which you can see that it is in lesser amount, so it is our solute. The 250 ml wine, the solution. So by using the formula, percent by volume is equal to volume of component in solution, which is the volume of our solute, divided by the total volume of solution times 100. By substitution, for the volume of a solute, the 35 ml of ethyl alcohol, and for the total volume of the solution is the 250 ml wine. So 35 ml divided by 250 ml. So cancel the units. Then 35 divided by 250 is equal 0.14 times 100 is equal to 14. So that would be our final answer. Our next example is colligative property, specifically the boiling point elevation. So what is boiling point elevation? It describes the phenomenon that the boiling point of a liquid will be higher when another compound is added, meaning that a solution has a higher boiling point than a pure solvent. So the formula of boiling point elevation is delta T equals I multiplied to Kb multiplied to M, where I is the Van 't Hoff factor, M is the molality, Kb is the boiling point elevation constant. So this is the example. 24 grams of NH3 ammonia was dissolved in 100 grams of water. Calculate the boiling point of the solution. So as I mentioned earlier, the formula for this is delta T equals I multiplied to Kb multiplied to M. So let's have the given. So I, our Van 't Hoff factor is 1. Why 1? You can notice that the compound used in our solute, NH3, the ammonia, is composed of the elements nitrogen and hydrogen, which are both nonmetals. They are molecular and not ionic. So automatically the value of Ri is 1. For our Kb naman, which is the boiling point elevation constant, is 0.51 degrees Celsius per molality. Para makuha naman ang molality natin, we should use the formula molality is equal to the mole of solute divided by the kilogram of solvent. Since ang given na solute is nasa gram, kailangan natin ito i-convert into mole. So 20 grams of ammonia times 1 mole of ammonia divided by the sum of the atomic weight of the nitrogen and hydrogen. So ang atomic weight ng nitrogen is 14. Ang atomic weight naman ng hydrogen is 1 times the subscript of the hydrogen, which is 3. So 14 plus 3 is 17. 24 divided by 17 is equal to 1.4. Para naman sa kilogram in solvent, ang 100 grams natin na solution is kailangan i-convert into kilogram. So 100 gram times 1 kilogram divided by the 1,000 grams, since 1 kilogram is equal to 1,000 grams. So 100 grams divided by 1,000 grams is equal to 0.1. So ngayon, magiging 1.4 the value of our solute divided by the 0.1 is 14. Since nakuha na natin ang I, ang Kb at ang molality natin ay pwede na natin i-substitute. So delta T, the change of temperature, equals I multiplied to Kb multiplied to M. Since ang change of temperature natin is equal to the difference of the final and initial temperature, equals ang I natin is 1 times Kb, the boiling point elevation constant is 0.51 degrees Celsius per molality, times ang value na molality natin na nakuha kanina na 14 molality. Ang initial temperature natin is 100 degrees Celsius. Since naka-negative siya, so i-transpose natin siya sa kabila. So magiging 1 times 0.51 multiplied to 14 is equal to 7.14. So since na-transpose na yung 100 degrees Celsius natin, yung initial temperature, makancel yung mga units natin. So ang material lang is degrees Celsius. So 7.1 degrees Celsius plus 100 degrees Celsius is equal to 107.1 degrees Celsius. So that is our final answer.
And our last example is calorimetry. Calorimetry is defined as the act of measuring changes in the state variables of a body for the purpose of deriving the heat transfer associated with the changes of its state to, for example, to chemical reactions, physical changes, or phase transitions under specified constraints. So calorimetry is simply the measuring of heat. The formula for solving it is Q equals M times C times delta T, where Q is our heat transferred, M for mass, C for the heat capacity, and the changes of temperature is the difference of our final and initial temperature. So this is the example.
Last example. How much heat is needed to heat 45 grams of water, which is 4.184 joules per grams degrees Celsius, from 25 degrees Celsius to 90 degrees Celsius. So we will find the heat transferred. The given are mass of 45 grams, the specific heat of 4.184 joules per grams degrees Celsius, the change in temperature, the 90 degrees Celsius minus 25 degrees Celsius, which is equal to 65 degrees Celsius. So as I mentioned earlier, the formula for heat transferred is Q equals mass times the specific heat times the change in temperature. So we will do substitution. So mass is 45 grams times the specific heat, which is the 4.184, times the temperature, which is 65 degrees Celsius. That would be 12,238 joules. So that is the measure of the heat transferred.